Good day, this is Antonio Caldwell, doctoral student at California Intercontinental University. This is GRC 605, Business Research Methodology and Quantitative Statistics with Dr. Joe Kappa. We will be reviewing today conducting a chi-square test of independence. Our agenda: first we'll look at the definition, data background, chi-square hypothesis testing, takeaways, and questions. The chi-square statistic is a non-parametric distribution-free tool designed to analyze group differences when the dependent variable is measured at a nominal level. We use the chi-square test of independence when you have two nominal variables and you want to see whether the proportions of one variable are different for different values of the other variable. The data set that we'll be using was generated using a SurveyMonkey survey asking participants that were located in the Midwest United States questions regarding their income, debt, savings, and other important financial factors. There were a total of 150 people surveyed. Our first hypothesis test will be looking at the relationship between the number of cars and the number of default payments. The following correlational test was conducted. Our null hypothesis: there is no relationship between the number of cars and the number of default payments. And our alternate hypothesis: there is a relationship between the number of cars and the number of default payments. The chi-square statistic and its p-value were calculated using PSP software. Assuming that alpha equals 0.05, no significant relationship emerged, or 9 degrees of freedom with the population sample. That population was 150. The chi-squared statistic resulted in a value of 9.7 with a p-value of 0.375. The chi-squared test failed to reject the null hypothesis, concluding that there is no relationship between the number of cars and the number of default payments. Our second hypothesis test, we're looking at the relationship between the linker comfort level and the number of default payments. The following correlational test was conducted. Our null hypothesis: there is no relationship between the linker comfort level and the number of defaults. Alternate hypothesis: there is a relationship between the linker comfort and the number of defaults. The chi-square statistic and its p-value were calculated using PSP software. Assuming that alpha equals 0.05, no significant relationship emerged. Again, we had 9 degrees of freedom with a sample size of 150. The chi-square statistic equals 9.7 with a p-value of 0.375. The chi-square test failed to reject the null hypothesis, concluding that there is no relationship between the linker comfort level and the number of default payments. Our third and last hypothesis test, we'll be looking at the relationship between the number of cars and the linker comfort level. The following correlational test was conducted. Null hypothesis: there is no relationship between the number of cars and the linker comfort level. And our alternate hypothesis: there is a relationship between the number of cars and the linker comfort level. The chi-square statistics and its p-value were calculated using PSP software. Assuming that alpha equals 0.05, a significant relationship emerged, 9 degrees of freedom with a sample size of 150. The chi-square statistic equals 450 with a p-value of 0.00 and a Kramer's V value of 1. The Kramer's V value indicated that there is a perfectly symmetric relationship between the number of cars and the linker comfort level. The chi-square test rejected the null hypothesis, concluding that there is a relationship between the number of cars and the linker comfort level. Looking at the Kramer's V interpretations, the strength ranges from 0.00, where there is no relationship to be considered, all the way up to 1 that's perfectly symmetric. This is a very rare. The dependent variable perfectly predicts the dependent variable. Some key takeaways. The chi-square test of independence is one of the most useful statistics for testing hypotheses when the variables are nominal. The chi-square test is a significant statistic and should be followed with a strength test such as a Kramer's V. Thank you for your time and thank you for listening to this presentation. I'll now open it for any questions.